Bismillahirrahmanirrahim. Nahmaduhu wa nusalli ala Muhammad Rasulullahi Kareem. If u is equal to x to the power y, so that del to u over del cube u over del square x dy is equal to del cube u over del x del y del x. ये हमको we have to prove this. We are given u is equal to x to the power y. Now take logarithm both sides so that we can easily differentiate with respect to x and y. So I take both sides log u is equal to log x to the power y. We know that according to log formula, this power will come here with multiply with log x, so we get log u is equal to y log x. I write it as equation number 1 because I will use it 2 times. First I use it for differentiating with respect to differentiating partially with respect to x. We get differentiation of u with respect to x. We get differentiation of log u is equal to 1 upon u. What it is not x, so I differentiate u with respect to x according to chain rule. It is left hand side, and in right hand side y is constant for x, so I take out y as constant and differentiation of log x is 1 upon x. Now I want to find the value of del u over del x, so that u must go in right hand side. By this we get uy upon x. I write it as equation number 2, and I want to find the value of del u over del y, so that we should differentiate equation number 1 with respect to y partially. So I write it here. Differentiating equation 1 with respect to y, we get, on differentiating log u, we get 1 upon u. What it is not y, so differentiate u with respect to y, we get del u over del y. On right hand side here for y x is constant, so take out log x as a constant and differentiate y with respect to y, which is equal to 1. Differentiation of y with respect to y is equal to 1, and now we are able to find del u over del y is equal to, on multiplying u on the right hand side, we get log u. We transpose u to right hand side and write it as a equation number 3, and we will use these two value of del u over del x and del u over del y in further calculation. So first of all, we want to find del 2 u over del y del x, because for left hand side, for right hand side we want this value. So I differentiate del x over del u over del x with respect to y, we get del 2u over del y del x. This value is in equation number 2, so I put this value from equation number 2. We write uy over x. For y, x is constant, so I take out 1 upon x as here, and only we have to differentiate u into v. Here we consider two functions of y, so differentiation y product, differentiate it y product rule, so we get first function write 1 upon x as it, and first function as it, and differentiation of y with respect to y is equal to 1, plus write second function as it and differentiate u with respect to y, we get del u over del y. And this value is we will write as u log x, because it is equal to u log x from equation number 3. 1 upon x, u into 1 equal to u plus y into value of this equal to u log x. This is value of del 2 u over del y del x. Now if we open this bracket, then 1 upon x multiplied to u, we get u upon x, and when x multiplied to here, we get y into u into log x upon x. This is value of del 2 u over del y del x. For right hand side, we want to value of del cube u over del x del y del x. We have find this value, so differentiate this value with respect to x, we will able to find the right hand side. Del y del x, it I solve here, so I put the value of this del over del x, which is equal to u upon x plus y u log x upon x. We have to differentiate this value term by term. There are two terms, so differentiate it. First term, differentiation of first term, which is also two function, we can consider it as u and multiplied by 1 upon x. There are two function, and also on differentiation this y is constant, so we take out y here as constant and differentiate only u log x and upon x. So differentiate is it term by term. Apply here product rule. So first function, right function, first function as it, differentiation of 1 upon x with respect to x is to 1 upon x square, plus second function as a differentiation of u is equal to del u over del x plus y into now apply formula numerator by denominator. We know that differentiation of this equal to denominator whole of square, numerator as it, denominator as it, and differentiate with respect to x, numerator u log x and minus u log x, differentiate denominator. By applying formula, we get this value. If I multiply u to minus 1, we get minus u upon x square. This value is equal to right hand side plus 1 upon x, but this value is equal to y upon x from equation number 2. So I write y upon x from equation number 2 plus y upon x square. Here what I write, we have to differentiate. I write x square denominator here, and here also we are saying there are two functions. So differentiation by product rule, write first function as a differentiation of second function, log differentiation log x equal to 1 upon x, plus write second function as it and differentiation of first function, which is equal to del u over del x, and write this value minus u log x, and differentiation of x with respect to x is 1. So it is complete it here, and we should write in next term, next page. This is value of right hand side, means this is value of del cube u over del x del y del x is equal to, first term is equal to minus u upon x square, and next term when multiply x to x, we get in denominator x square uv upon x square, we get uv upon x square plus uy upon x square, uy upon x square plus y, we can write x square with the y, so it becomes y upon x square, and numerator will be written in this square bracket, write x, and it is y upon u upon x. If I open this bracket and x multiply to here, then x cancel out by this, we will get only u. So I should write here only u. So I should write here only u, and in next term, which is plus and u multiply to in log x, we get x log x, x log x, and del u over del x. These are two terms, and last term which is equal to minus u log u, minus u log log u, close bracket, bracket close, and this value is equal to minus u upon x square on u upon y, uy upon x square on opening this bracket, and y upon x square multiply to this term, we get u into y upon x square, which is equal to this term, means like terms, these are two like terms, and y upon x multiplied to here, we get x cancel to this power of x, we get y upon x, and log x into del u over del x, minus y upon x square multiply to here, we get u into y log u upon x square. And now we have to put the value of del u over del x from equation number 2. We write this value, and here u upon x square plus these are like terms, so we can add up in this, because this is 1 times it is becomes 2 times u y upon x square. Now I so write the value of del u over del x. The value of del u over del x, but here we have to write log x, and after it I should put the value of del u over del x, which is u y upon x, uy upon x from equation number 2, using equation number 2 here, and last term is uy log u over x square, on multiplying x y into y square and x into x square, then we obtain del q u over del x del y. Del x is equal to minus u upon x square plus 2 times u y upon x square plus y into y square, x into x square upon me in denominator, and also here y u and log x, u log x we have to write here. So all the factors are written here, and whole term this minus last term is u y log u upon x square. This equation is nothing but equation right hand side, so we should find the value of left hand side. For this we differentiate del u over del y 2 times, we will get the result. So differentiate equation 3 2 times with respect to x, we get left hand side. So differentiate equation 3 differentiating equation 3 with respect to x partially we get del 2u over del x del y, because we have find del u over del y. So I put the value of del u over del y from equation number 2, which is equal to u log x. Now we should differentiate it considering first and second function, and means product of two functions. So first function as it differentiation of second, which is differentiation log x is 1 upon x, plus second function as it differentiation of first function, which is equal to del u over del x. Value of this we can write from equation number 2. U into 1 is u upon x plus log x into this value from equation number 2 using equation 2. And this value is del u over del x. Del u over del x is u y upon x. U y upon x. Now we should differentiate it again with respect to x, partially differentiating equation differentiating again with respect to x partially we get del cube u over del x square del y, because it is nothing but differentiation of del 2 over del x del y with respect to x. But this value is we have find here del 2 u over del x del y. So I put the value of del 2 u over del x del y, which is equal to u upon x plus u v, I write here first, and then log x upon x, and differentiate it term by term. So I differentiate first it and consider u and 1 upon x, it is s, and differentiate on differentiation it because it is partial differentiation. So for x y is constant, so only we have to differentiate u log x upon x with respect to x partially. Consider first and second. So first function u write as is as it, and differentiation of 1 upon x equal to minus 1 upon x square, plus differentiation second function as it differentiation of first function is del u over del x. Now we have to differentiate this according to formula, numerator by denominator formula, plus y and apply formula. We know that it is denominator square here. First I I write denominator square and write denominator as it, and differentiate numerator with respect to x, which is u log x, minus write numerator as it u log x, and differentiate denominator which is equal to x. Now on opening the bracket, u multiplied to here becomes u upon x square plus 1 upon x into value of del u over del x. Put this value from equation number 2, we can write u y upon x, u y upon x plus we can write it as y upon x square beneath y, and only numerator we will write here on solving, taking u as a first function and log x is second function. Apply product rule, first function as it, differentiation of second, plus second function as it, differentiation of first, and after it I write u log x, and differentiation of x is with respect to x1. I think I have calculated this calculation previously. U upon x square plus x into x becomes x square, u into v is in numerator, plus y upon x square. When we open this bracket, x multiplied to this two terms, and then x cancel out, we get u, and x multiplied to this second term, we get u log x and del u over del x minus u log x. Now from equation number 2, we put the value of del u over del x minus u upon x square plus u y over x square plus y upon x square u plus x log x, and put the value of del u over del x from equation number 2, u y over x. This is value of del u over del x from equation number 2. Using equation number 2 minus u log x, write as it without any change, and after it minus u upon x square plus u y upon x square. Open this bracket, we get u y upon x square and multiply to this term. Here we see that x is cancelled out this, and we get y into y is square, and write u first and then log u log x, and here x square in denominator. When this value multiplied to this, we get this term, and this multiplied to here, we get also minus uy upon x square and log x. Here I write u in the term. It is wrong because you have see that when I commit a mistake in finding the value of del u over del 3u over del x or del y del x, when I put the value of del 2u over del y over del x, which is equal to this, I differentiate this value. There is no mistake. There is also no mistake when I apply this here. But after this step, I write here log x as a here. What in this term I log it, I write u log as u log u log we should write it u log x. So there is no problem. U changes because I not operate I not do any operation here, only it is written as it u log x we can change because here there is no operation, so no effect on our calculation. So write it u log x as you consider, and I commit a mistake, so write it u log x, because when we compare this value, because this value in last we have find this value which is equal to del q over del x square del y, del cube u over del x square del y. I write it as equation number 5 and match equation number 4 and equation number 5. But after one step we get del q over del x square del y. My right is this term u over the x square, and what these two terms when add up we get del u over del y over x square, and write it this equation as y square u log x upon x square and minus uy log x upon x square. Write it is as equation number 5, and from 4 and 5 we are seeing that right hand side are both equation are equal, so left hand side also, so we can write it is as del cube u over del x square del y equal to del cube u over del x del y del x, which was to be proved. Thank you very much indeed for listening me. Wa akhir dawana alhamdulillahi rabbil alamin.